For Module 4, we'll take a look at a problem with multiple flow units. So here we have a process consisting of 5 different resources that are operated 8 hours per day. And the process works on 3 different products, A, B, and C. So here we have the number of resources at each resource, the number of workers at each resource, and the processing time for each of the products A, B, and C. And we are told that demand for the 3 different products is as follows. Product A is demanded 40 units per day, product B 50 units, and product C 60 units. So we're asked to figure out what the bottleneck is, and then also figure out what the flow rate for each flow unit is, assuming that demand must be served in a mix of 40 units A to 50 units B to 60 units C. So we will start off by calculating how many minutes are worked per day at each of the resources, which is just taking the number of workers at each resource times 8 hours worked per day times 60 minutes per hour. So for example, in number 1, we have 2 workers at the resource who are working 8 hours a day and then 60 minutes per hour. So they're working 960 minutes. So it's the same at resource 2. It is half of that at resources 3 and 4. And then 960 again at resource 5. And then next we will look at the capacity requirements for each of the resources for products A, B, and C. So what we're doing there is we are taking from the table we are given the processing time for that product and multiplying it by the demanded units. So if you recall, we have the processing time for each resource for products A, B, and C, and we'll just be multiplying each of these numbers by the quantity demanded. So 40 for A, 50 for B, and then 60 for C. So just to map that out for the first one, we have a processing time of 5 minutes for product A, and 40 are demanded. You have a processing time 5 minutes for B, and 50 are demanded, and then a processing time again of 5 and 60 are demanded for C. And then if you do the similar math for all remaining, this is what you should get. And then we're going to calculate the total workload per day, which is the sum of these 3 requirements for products A, B, and C. So just adding all of those together. And then to get the implied utilization, we'll take a look at demand over the capacity of the workers. So for example, resource 1 is demanded 750 minutes of work, but he is able to work 960. So he has an implied utilization of 78%. So you'll see here that resource 3 is our bottleneck because it has the highest implied utilization. And resource 3 is only used to produce product A, and it's still overconstrained. So we cannot produce A at a rate of 40 units per day because we're overutilized by 25%. So we can quickly calculate and figure out how many units per day we can produce, which is 32, which with an 8-hour workday equates to 4 units per hour. And then if we are maintaining that fixed mix between products A, B, and C of roughly 40 to 50 to 60, you can see the flow rate for A is 4 units. For B, it will be 5 units per hour. And for C, it will be 6 units per hour.